Hey everyone, welcome to another video, and this video is all about finding the square root of the perfect square numbers using the prime factorization method. It's a very simple and very reliable technique to find the square root of any number which is a perfect square. So let's get started. Now the first question is, what is prime factorization? So before we jump into finding the square roots, we need to understand what is prime factorization. So prime factorization is actually when we break the number into the product of its prime numbers, into the product of only prime numbers. So when we are writing a given number as the product of the prime numbers, that means that is a prime factorization. For example, if I want to find the prime factorization of 36, I can use the factor tree method to find the prime factorization of 36. Now, 36 is divisible by 2. So 2 times what number is 36? It's 18. 18 now is 2 prime, yes, but 18 is composite. So I will again split 18. So it is 2 times 9. 2 is prime, 9 is composite. Let's split this 9 and write it as 3 times 3. And I notice that my prime factorization is complete because I have reached at the step where 3 and 3 are prime numbers. And of course, I cannot split it further. So 36 can be written as 2 times 2 times 3 times 3. 2 times 2, 4. 4 times 3, 12. 12 times 3, 36. So that's the prime factorization of 36. Let's check one more. So 100. So I can divide 100 with 2 and 2 multiply by 50 gives me 100. 2 is of course prime. 50 is not. So I will split it further. 2 times 25, 2 prime. 25 can be written as 5 times 5. And now I can see that 100 can be written as 2 times 2 times 5 times 5. And that is the prime factorization of 100. Um, One more. Let's take 225. So 225, if I multiply it with, if I split it as 3 times what? So 3 times 7 is 21, 3 times 5 is 15. Okay, so 3 times 75 is 225. And then again, 75 is divisible by 3. So 3 times 2, 6, 3 times 5, 15. 3 times 25. 25 is of course 5 times 5. So now I can see that all these numbers are the prime numbers. So these are the prime factors of 225, and the prime factorization of 225 is 3 times 3 times 5 times 5. So this is what the prime factorization is: splitting or breaking the number or writing the number into the product of only the prime numbers. There should not be any composite number, only prime numbers or prime factors should be there. Now, how to find the square root using this method? So let's take our first example. Find the square root of 36 using prime factorization. So let's find the prime factorization of 36. 36 can be written as 2 times 18, 2 prime, 18 not. 2 times 9 is 18, 2 prime, 9 is not. 9 can be written as 3 times 3 and 3 is prime. So the prime factorization of 36 is 2 times 2 times 3 times 3. I want to find the square root of 36. So I will take the square roots on both the sides. So root 36 is equal to root square root of 2 times 2 times 3 times 3. Now, the next step is to pair the factors. That means I will be pairing this factor and then I'll make the group or the pair of this factor. So root 36 is equal to, and now my next step would be to write one prime factor for each group or for each pair. So for this pair, I would write 2 times, and for this pair, I will write 3. So root 36 is equal to 2 times 3, 6. That's all. Very easy. Now, how to verify that my answer is correct or not? If square root of 36 is 6, what is 6 square? Is it 36? Yes, that means my answer is correct, because squaring and taking the square root are inverse operations. If square root of 36 is 6, then 6 square must be equal to 36, and we know that 6 square is 36. That means my this answer is correct. All right, next one. Find the square root of 144 using prime factorization. Let's find the prime factorization of 144. So 144 can be written as 2 times 72. 2 is prime. 72 can be written as 2 times 36, 2 prime. 36 is 2 times 18. 2 prime. 18 is 2 times 9, 2 prime. And 9 is finally 3 times 3, and we know that 3 is a prime number. So 144 prime factorization is 2 times 2 times 2 times 2. This 4 times, and then I have two threes. So 3 times 3. So if I want to find the square root of 144, I will take the square root on both the sides. And now what would be my next step? To pair each prime factor. So I will pair this one, I'll pair these two, and I'll make the pair of these two. And finally, my square root of 144 is to write one prime factor for each group or for each pair. So for this pair, I would write 2. For this pair, I will write 2. And for this pair, I'll write 3. So square root of 144 is equal to 2 times 2, 4. 4 times 3 is 12. Is this correct? Of course, because we know that 12 square is 144. So that means my answer is correct. Find the square root of 4096 using prime factorization. So let's find the prime factorization of 4096. It's a big number. So of course I will have many prime factors. So first I'll do with 2. So 2 times 2048 is 4096. Then this will give me 1024. This will give me 2 times 512, 512. This 512 is 2 times 256. 256 is 2 times 128. And 128 is 2 times 64. Okay, I'll split this 64 on this side. 64 is 2 times 32. And 32 is 2 times 16. 16 is again 2 times 8. 8 is 2 times 4, and 4 is finally 2 times 2. Okay, because the number was big, so of course we will have many prime factors. So 4096 prime factorization is, I can count how many times I'm getting 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times I'm getting 2. So I will write it 12 times, and this is 8 times, and this is 12 times. I hope I'm correct. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Perfect. Now to take the square root, take the square root on both the sides, and then we know what we have to do. We have to pair the factors. So make the groups or pairs of each factor. So this pair, this pair, this pair, and this one and this one. So square root of 4096 is now, for every pair, I will write the prime factor once. So 2 times 2 times 2 times 2 times 2 times 2. And now 2 times 2, 4, 2, 8, 2, 16, 2, 32 times 2 is 64. So square root of 4096 is 64. My next question is 252 a perfect square or not? So even if I know that 252 is not a perfect square from the knowledge of my perfect square numbers, but still, if I want to show it by prime factorization method that how it is not a perfect square, how will we show that? So if I take the prime factorization of 252, so it's 2 times 126. 126 is 2 times 63. 63 is 3 times 21. 21 is 3 times 7, and that's it. 7 is prime, correct? So that's the prime factorization of 252. So 252 is 2 times 2 times 3 times 3 times 7. Now to take the square root of 252, let's take the square root on both the sides. And now what is our next step? To group the factors or to pair the factors. So one pair is this, one pair is this. Are we able to pair 7? No. This 7 is left. Since we are not able to pair this 7 and this 7 is left, there is no group or other 7 by which I can make a pair. So 252 is not a perfect square. Why? Because that 7 prime factor is left out. I cannot make the pair of 7. That's why 252 is not a perfect square. There should be all the prime factors should be paired with the another prime factor. This one is left. I cannot do anything for that. So 252 is not a perfect square. Hope this prime factorization method is clear to you. If you have liked the video, please hit the like button and subscribe to my channel. And what is coming next? The next one is to find the cube root by the prime factorization method. So bye bye. See you in the next one.